The U.S. military is conducting strikes on the Houthis command and control nodes from the Red Sea using the tried and tested F-18 fighter jet using JDAMs and the AGM-88 missiles, while the United Kingdom will be deploying the Eurofighter Typhoon using the Paveway series of bomb and the Storm Shadow missile for destroying heavily fortified bunkers. However, the United States military is not only fighting from the air but also extending its reach to the sea. This involves deploying its heavyweight aircraft carrier, the USS Dwight Eisenhower. Additionally, U.S. destroyers will be patrolling throughout the Red Sea to provide protections for the shipping vessels. Lastly, a silent nuclear-powered submarine will be launching Tomahawk Cruise missiles targeting munition depots, launching systems, production facilities, and air defense radar systems. This is the JDAM glide bomb, breaking it down into smaller pieces. This is essentially a dumb bomb upgraded with a guidance kit, transforming it into a smart flying munition. All in the video ahead, so stay tuned and don't miss a beat. Scenario 1. The U.S. deployed 22 fixed-wing aircraft, including F-18s, from the Dwight Eisenhower aircraft carrier in the Red Sea region. Once the targets are identified in Yemen, these F-18s are launched from the aircraft carrier. Before launch, the GPS navigation system is initially transferred from the aircraft, providing position and velocity vectors from the aircraft systems. Once released from the aircraft, the JDAM or JDAM-ER and Paveway bombs autonomously navigate to the designated target coordinates. These weapons pack a punch, traveling around 45 miles, approximately 72 kilometers deep inside enemy territory with this converted kit, all at a fraction of the cost compared to Tomahawk Cruise missile. These are suitable for stationary bunkers missile launch sites like the Mohit missile or the Soviet-era P-15. Interestingly, these dumb bombs, in its most accurate mode, the JDAM system, will yield a weapon circular error probable of 5 meters or less during free flight when GPS data is available. Scenario 2. The United Kingdom, interestingly, did not bring its aircraft carrier but utilized 4 Typhoon jets from Cyprus, a major UK airbase located here. Additionally, 2 Voyager air-to-air refueling tankers were used to extend the Typhoon fighter jet's mission duration. After refueling, they fly south towards Yemen. It is here the UK will likely employ their tried and tested weapons, such as the Storm Shadow, made in collaboration with France, and the most cost-effective Paveway series of smart bombs. When ready, the Storm Shadow can be fired from the Typhoon fighter jet in the Houthis-controlled area in Yemen. These weapons are specially designed to destroy heavy bunkers, featuring a precursor bomb followed by a follow-through warhead. Let's examine the operations in basic step-by-step format. Step 1. The aircraft releases the missile. Step 2. After a few seconds, the missile opens its 2 wings. Step 3. It initially uses inertial and GPS guidance in the first stage. Step 4. The missile drops to low cruising altitude, identifying its position using GPS, flying below radar and close to the ground. Step 5. In the final stage, a thermal homing head and terrain countermatching guide the missile. Consider a simple bunker as a target with 2 layers of soil and concrete. The contact sensor detects a target. The armor-penetrating precursor releases a jet of hot metal, penetrating up to 4 to 5 meters or 16 feet of concrete. Remember the 2 warhead we talked about earlier. It is at this stage the follow-through bomb separates from the missile, penetrating the structure. If a fuse is set in delay mode, it will explode within the bunker, maximizing the damage inside. Not to forget the Paveway series of bombs that cost around $30,000, while the Storm Shadow costs an astronomical $3 million. This makes the Paveway one of the most economical guided weapon for the Royal Air Force. At the front is the guidance system. In the middle is the 500-pound warhead, which can penetrate concrete, and the tail represent the guidance section for the control surfaces. When dropped, the Paveway represents a dual-mode weapon. It uses both GPS and can be laser-guided to the targets, especially effective against mobile assets. This weapon looks for the reflected energy of the laser and is dropped precisely, destroying the vehicle into pieces when hit. Scenario 3. This is a nuclear submarine that can be positioned very close to the Yemeni shoreline. The submarine can stay submerged for almost 140 days, waiting for targets many miles away and hit these launching pads. The reason for using this submarine is to target enemies that become mobile after firing rockets. typically after 2 hours or more. This strategy allows the slow-moving Tomahawk Cruise missile to reach its target much faster. That's why these submarines are stationed very close to the border. Now let's take a look at how it is fired from inside the submarine. Step number 1. The submarine will ascend to an assigned depth. Step number 2. When ready to launch, it will open the hatch, and the protective seal will break open. Step number 3. High-pressure compressed air is pumped into the tubes, and this is used to eject the Tomahawk missiles. Step number 4. The missile's tip will emerge above the water's surface. Step number 5. The rocket boosters fire and propel the missile into its path. Boosters fall off as soon as the missile is out of the water. Step number 6. The main engine of the Tomahawk missile will engage, and then it will open its wings, just like the animation shown here. It is at this stage the missile becomes a cruiser and flies towards the designated target and does pack a punch, destroying almost any launcher provided it's stationary. Scenario 4. This is an Arleigh-Burke-class destroyer that can be stationed in the Red Sea. It can carry more than 90 Tomahawk missiles. These cruise missiles are used for tactical land strikes and can travel up to 1,550 miles, which translates to around 2,500 kilometers. The destroyer uses the Mark 41 vertical launching system. The cells are equipped with launchers that use compressed gas to eject the missile from the cell and into the air. The missiles are then ignited and propelled towards their target. The cruise missile can open its wings and glide to its designated target, entering Houthis territory to hit missile launch systems. The F-18 utilizes various weapons such as the AGM-88, or one of the most commonly used guided bombs, the Joint Direct Attack Munition. When upgraded, it is referred to as a laser-guided JDAM. Breaking it down into smaller pieces, this is essentially a dumb bomb upgraded with a guidance kit, transforming it into a smart flying munition. Let's take a quick look inside this weapon. At the front is the guidance system, and just behind it is the warhead, weighing around 2,400 to 500 pounds depending on the variant, which translates to around 1,088 to 226.7 kilograms. Moving to the back, there is the inertial guidance kit and military-grade global positioning unit. Here is the adapter ring for the telemetry antenna and the encryption key battery. Moving further back, we find the thermal batteries and composite fins that help steer the missile towards the target using gears, which will require another detailed video to help you understand its control surface. Not to forget, these can also be upgraded with wings. The 500-pound JDAM ER variant features a modular add-on wing kit that utilizes the small-diameter bomb glide technology. The wings unfold in flight and triple the range of the older weapon. This helps increasing its range from 15 miles to more than 45 miles, that is around 72 kilometers, to the designated target, just as shown in this animation. We make original 4K 3D animation with this small team of animators. So please support us by subscribing and dropping in a comment for more exclusive engineering animations made just for you guys.